Hi there. A while ago I had a bit of an email exchange with a guy called Alan Sills. I think he lives in Spokane, Washington, USA. And he recommended a couple of books. One called Two Shot Masters, which features a guy called Philip Duclos. I think that's how you pronounce his name. And The Shop Wisdom by Philip Duclos. And one of the main reasons for recommending them was the fact that these two books have got 6 different engine designs in them by Philip Duclos. And in addition to that, they've got all sorts of other things like tools you can make for your workshop and methods to follow and stuff like that, packed with information. So after thinking about it, I thought I'd sort of splash out and buy them from the US, and they arrived a few months ago. Now, I also recently got into a conversation with a guy called Earl Abbott, and I happened to mention these two books, and I think he certainly got that one, and we got talking about Philip Duclos, and we thought it might be a good idea to have a bit of a collaboration and make one of Philip Duclos's engine. So having looked at the various designs, we've sort of come up with having a go at making one called an odds and ends engine. It's a hit and miss engine. It's copyright, so I won't show you plans, but that's sort of what it looks like. And the reason it's called an odds and ends engine is because it's supposed to be made out of sort of various bits of scrap metal you've got kicking around the workshop. But I mean, unfortunately I don't have a lot of scrap metal kicking around the workshop. And some of this stuff is, albeit the engine's sort of reasonably small, so some of this sort of angle iron and plate is quite substantial. So I'm going to have to order the various bits and pieces. But the intention is to actually make, in collaboration with Earl, each of us make one of these odds and ends engine. So in this video, this will be the first of the series, and I'll be making, what's they call it in here, the engine base unit. So the base of the engine is made out of these 3 pieces of metal, and the idea is that will actually be the bottom, and then those will go sort of like that. But to achieve that, these need to be reduced down to a width of about 1 inch. So I'll try and cut most of that off on the bandsaw. Well, this is a little bit convoluted, but all being well, it'll work out okay. Oops. Catching a bit, isn't it? Try again. Put a bit of oil on it. Blimey, that took a long time. Well, I think I'd be pretty much scuppered without that bandsaw, and it was just big enough to fit these pieces in. So that's sort of the idea. So what I need to do now is to go over to the mill and mill these down to dimension. So before marking these up, we need to take a light cut off the base of the feet. So now is probably a good time to actually reduce this dimension down to 1 inch. So these feet need to be 1 inch from the centre. So I've put this wiggler on just to make sure that we're centred on the y-axis, and we are. So I've zeroed the DRO, the y-axis, and I'm going to use this 10mm cutter, this end mill, to mill the sides. Now, with it being 10mm, if I have that, I get 5mm. So the measurement on the DRO needs to come to 1.197. So what I'll do is I'll start off on the edge, taking 10th increments off until I get to that measurement of 1.197, and then I'll repeat the same process on the other side. Blimey, that took a while, so I need to repeat the same process on the other side, but I'll do all that off camera. Okay, so I've milled the sides to make sure they're perpendicular with the bottom of the feet, and they are. And I've also marked them up based on the drawing dimensions, and the marks are quite difficult to see. I've done the base as well. So what I'm going to do first of all is I'm going to mill these angles on the sides. Having done that, I'm then going to drill the holes for the bottom and the base and get it attached to the base to make sure I can do that properly. Once I've done that, I'll take these off the base again, and then I'm going to use this template to guide me when I'm doing rough cutting. So I think what I'll be doing is maybe drilling through with a drill bit or a slot drill, and then joining up the holes with the bandsaw. So that's the plan. Okay, so on this side there's a requirement to mill this side at an angle of 5.5 degrees. Now it's not a critical angle, I don't think, and I've sort of scribed a line on there, but it's pretty faint. So I was thinking about how best to do it accurately. So I think I'm going to use this sine gauge here, which is a 2-inch sine gauge. So if you take the sine of 5.5 degrees, you get round about 0.0958 of an inch. So if you multiply that by 2, because it's a 2-inch sine gauge, you get 0.192 of an inch. So I've put some slip gauges under here, 0.192 of an inch. And I've adjusted the vise so I get this square at 90 degrees. That's spot on. So I'm pretty confident that when I machine this off, mill it off, I'll get exactly 5.5 degrees. And I'll do the same on the other side, but the other side is a bigger angle. It's 14 degrees, but I'll use the same method, I think, but I'll do all the machining off camera. Well, this is the 14 degree angle I'm cutting here, and I've decided to cut each piece individually. It's taking forever. I was thinking about cutting the bulk off with a bandsaw, but to be honest, it's probably going to take as long to do it on the bandsaw as it is with the end mill. But I'll get back to you once I've completed both of them. Well, there's a lot more metal to come off this here, but before I take that off, and with it being a nice straight edge that's parallel with the base, I'm going to put it in the vise and drill the holes and tap them for the bolts. And I'll do the same for the base as well at the same time, and then we can assemble it and make sure everything's looking good, and then I can tackle getting rid of all of this material here. Well, I know my vise jaws are parallel with the bed, but I've just put this gauge on here just to make sure that this face here is parallel as well. And that's looking good. So what I'll do is I'll put an edge finder on here, find the edge, and then I need to drill and tap 3 holes which are exactly 1/2 inch from this face. So what I need to do is to take the edge finder out and move the y-axis this way 3mm, so I'm exactly on this edge. Having done that, I'll put a centre drill in and move the y-axis this way again exactly 1/2 inch, and I'll start centre drilling and drilling and tapping. Now I've approached this differently from what the instructions suggest. The instructions reckon that rather than sort of drill and tap first of all, you sort of somehow attach them
clamp them to this base and then drill through from the base and sort of like spot drill to mark these sides, but I couldn't work out how to sort of hold these properly on the base, so I've approached it in this way, and having drilled and tapped M6, what I'm going to do now is drill the clearance holes for the bolts, and all being well it'll work out okay, assuming I get my measurements right. Well, I couldn't have wished for a better result than this. Looks perfect. I've sort of pre-drilled these holes as well to hold the cylinder block on. They'll need to be drilled right through at some stage. Very happy with that. So what I need to do now is to take it apart again, and then I can start to remove all of this material here. And I think I mentioned previously I'll probably use some slot drills or something like that to go around, and then maybe the bandsaw, I don't know. But once I've got the majority of the material out, I'll reassemble it and I'll mill it in position like that. So that's the plan. Well, this is going to take a while for sure. Wow. Well, I'll continue doing the rest off camera. So now I need to join the holes up with the bandsaw. Well, this is the first time I've used this bandsaw in this manner, but we'll give it a try. Well, it seems to be going to plan, and I'll continue cutting through these holes. I'll do it off camera and then I'll get back to you. Now, the instructions in the book suggest milling this angle here first before attaching the sides to the base, but I'm not going to do that. I'm going to mill the tops of these areas to the correct height first of all, and to do that I've bolted the sides to the base. And I know that this height I'm looking for here is going to be 1.4375 of an inch, and this height here needs to be 2.375 of an inch. Now, I've put this 123 block in here, which I know is 60 millimeters in height. So I've touched the tool on the top of it. I've zeroed the readout on the quill, and I've set the Z-axis DRO to 60 millimeters to equate to that. So by adding up the readout on the quill and the readout on the DRO for the Z-axis, if I add those both together, that gives me the correct tool height. So that's how I know how high I need to mill to here, because I know the combination of both those values needs to be 1.4375 of an inch. So the Z-axis at the moment is 1.66889. So if I take 1.4375 off that, I get 0.231. So I'm aiming here for 0.231. 10th out of time or thereabouts. Okay, so I've just taken off the mill just to measure the height of these machined surfaces, and this height here needs to be 2.375 from the base. Now I've zeroed the height gauge on the base, so I'm looking for 2.375. And I've got 2.38. Five thou out. Happy with that. And this one I'm looking for 1.4375, and I've got 1.4355, so again I'm happy with that. Okay, so I think I'll take the opportunity to mill out the recess for the bearing blocks, and also on this side here, both sides here need to be reduced by 1/16 of an inch, leaving the centre at this original height. So that's creating sort of like a location, sort of like key that fits into the cylinder block. So I've just run this gauge along this face here just to make sure that we're nice and parallel with the bed, and we are. So I've just put this wiggler on so I can zero the x-axis at this point, because the drawing takes all measurements from that point onwards. Okay, so the centre of the cutout for the bearing blocks needs to be 1¼ inches from that corner that we've just zeroed on the x-axis. So this wiggler is actually pointed on the centre of where this bearing block is going to be cut. Now I'm going to use a 12mm cutter. It needs to go down to a depth of 0.375 of an inch. So I'll mill out that section first of all on the front and the rear bearing block. Once I've done that, I'm then going to move the x-axis left by about 0.264 of an inch and mill that section out, and then right the equivalent 0.264 of an inch, and that should give me an inch wide recess. But I'll do all this off camera. Well, I'm usually quite conservative cutting metal. I usually go in 10th hour increments, but I've just put this new cutter in, and I'm cutting in 20th hour increments, and it's working a treat. melting like butter. Well, it's starting to take shape now, so I've marked up these 2 lines here. So now I just need to work out how to hold it in the mill and mill it down to those lines. Well, I bought this spice from Archeoro Trade a while back. It's my 3rd one of this type. It's the Type 2 Precision Engineer one, and they're really good vices. The jaws just do not lift, and it's the first time I've really used this on this job, or any job, because I just thought it'd be too big, but for this job it's perfect. Well, I've just had a really nice surprise delivery. My neighbour, he does some work for a local engineering company, and he's just been there today, and they were throwing loads of gear out, loads of tools, and he brought me a box which he just put outside and left it for me to collect, and I can't even lift it. I've had to get it onto the lifting table. So it's only a box that big, full of tools, full of them. Now I've just had a quick look, and I mean there's a test bar. Oops. I don't know how accurate that is. There's some end mills here, 4-flute end mill, never used by the looks of it, 20mm, made in Austria. Another one, never used, another 20mm, 6-flute, looks part used. A tap, 7/8 B14 UNF. Like I said, there's loads of them. Some of these I can't accommodate on my mill, and some of them have got a funny thread connector, but some will work with my collet chucks. I think even that's got a threaded end, I think that might go in a collet chuck. That slot drill, you start getting a bit bigger, so again I couldn't do much with that. I don't think I can do much with this. God knows what that came off. Good doorstop. But anyway, onto this little engine. So I can't believe how long it took me to machine this. But I'm really happy with the end result. but it wasn't the job I was looking forward to. Yeah, it has come out okay in the end, and I think Earl has started. I think he's actually made the piston and the cylinder. So I'm not too sure what I'm going to make next time. It might be the cylinder block, maybe. I don't know. I need to give it some thought. But I'm really happy with the way it's turned out. And I hope you enjoyed the video. And I hope to see you later.